Big congratulations to the Indian Space Research Organization, who of course successfully landed their spacecraft Chandrayaan-3 on the Moon on the South Pole. India's Chandrayaan-3 mission has spent nearly a week on the Moon after it landed in the South Polar region on August 23. The mission, led by the Indian Space Research Organization, has made India the fourth country to achieve a soft lunar landing and the first to reach the southern polar region of the Moon. The Chandrayaan-3 mission, which began its lunar orbit in early August, has been conducting a series of experiments since its successful landing. The Pragyan rover, housed within the Vikram lander, has been deployed to carry out these experiments over a period equivalent to 1 lunar day, or 14 Earth days. One of the key experiments conducted by Chandrayaan-3 involved preparing a temperature profile of the lunar topsoil. This was achieved using an instrument named CHAS-T, equipped with a temperature probe and 10 individual sensors capable of reaching a depth of 10 centimeters below the surface. The data collected from this experiment has provided the first temperature profile for the lunar South Pole, offering valuable insights into the Moon's thermal properties. Meanwhile, the rover has successfully navigated its first obstacle, proving its robustness and strength. Pragyan negotiated its way around a crater on the Moon on August 27, just days after it began walking on the lunar surface. The six-wheeled rover is working on solar energy and is expected to function as long as sunlight falls in the southern polar region of the Moon. In addition to temperature profiling, the Chandrayaan-3 mission is also studying lunar quakes, mineral compositions, and the presence of water ice on the Moon's surface. The radioanatomy of moon-bound hypersensitive ionosphere and atmosphere experiment on board the lander is studying the electrons and ions near the lunar surface and their temporal changes. The success of the Chandrayaan-3 mission has been widely celebrated, both in India and globally. Former NASA official Mike Gold lauded the mission as a victory of Indian innovation, highlighting the relatively small amount of resources used by India to achieve this feat. Social media mentions of the mission have also been high, with Delhi topping the list of cities where Chandrayaan-3 was most discussed online. As the mission continues, the world eagerly awaits further updates from Israel about the findings of Chandrayaan-3. The mission's success serves as a stepping stone for future lunar explorations and a testament to India's growing prowess in space exploration. While Vikram and Pragyan have a planned mission life of 1 lunar day, which is 14.75 days on Earth, there is a possibility that the duo could live longer. ISRO has designed its lander and rover to harness solar power and charge its onboard batteries. But that would be possible only during the lunar day. After lunar day comes lunar night, when temperatures drop severely and go well below -150°C. If the lander and rover survive the lunar night, it might be possible for them to get revived when the lunar day breaks and solar power is available. Multiple ISRO. In fact, ISRO has planned the lunar landing at the start of the lunar day, so that the lander rover can harness solar power and work for the planned operational life of 14 Earth days, or 1 lunar day. Earlier on 9 August, ISRO Chairman S. Somanath had sent the lander of India's third lunar mission, Chandrayaan-3, Vikram, will be able to make a soft landing on the Moon's surface even if all the sensors and 2 of its engines do not work. The entire design of the lander has been made in a manner that makes sure that it would be able to handle failures. Somanath had said, quoted by PTI, "If everything fails, if all the sensors fail, nothing works. Still Vikram will make a landing. That's how it has been designed, provided that the propulsion system works well," Somanath said. He'd also added, "We have also made sure that if 2 of the engines in Vikram don't work this time also, it will still be able to land." The really interesting part of this sequence is when it finally gets through the rough braking phase and begins the fine braking, the careful maneuvering, the hovering, the translation as it approaches the plant, the surface of the Moon. And the way you know it's in this phase is the spacecraft really changes orientation and then pauses for a moment as it surveys the landing site, makes a translation, and eventually descends onto the surface, making some adjustments here and there. And then right at the end, we get a little flash of those thrusters kicking up the regolith in a way that only Chinese spacecraft have managed in recent years. And of course that meant much celebrating not just around the control room, but around India in general. And Prime Minister Narendra Modi too, waving a flag on the screen because he couldn't be there because he was at the BRICS conference. Now, the spacecraft couldn't stop to celebrate. It had to get right to work. Its time on the surface is limited by the sunlight. When the sun goes down, the spacecraft is probably not going to wake up again. So it begins by deploying the ramp for the rover. The rover deployed a solar panel and lowered down the ramp. There's actually wires that are used to slowly lower this down towards the lunar surface. Now, if you look carefully at the wheel nearest the camera, you might catch that there's some features on it designed to leave imprints in the lunar soil. Now it looks like the rover spent a day or so at the bottom of the ramp. Probably checking systems out, charging its batteries before it finally proceeded out beyond the immediate vicinity of the lander and turned itself. Why did it turn itself? Well, that vertical thing coming up, those are the solar panels. And you notice that it turned to align its solar panels with the sun. We can get an idea of how long the rover deployment took by looking at the shadows. Here's at the top of the ramp. Here is what it looks like when I've moved further down the ramp, and you see the shadow of the lander is starting to come down, and by the time it's moved a long way out, the sun is much higher up. So presumably, with full consideration given to the rover's limited lifespan, it's going to set out at some point and start trying to do science on things. The two instruments that it has is an alpha particle X-ray spectrometer, where you hit a rock with your alpha rays and you check the X-rays that come off. And then there's the light-induced breakdown spectroscopy, which hits the rock with a laser and sees what kind of light comes off. Also, for those instruments, it has a range of 500 meters, so there's no way that it's going to get over and meet the Chandrayaan-3 rover. Immediately after landing, there was some question about where the actual touchdown coordinates were. And of course, people on the internet began working to find this out. And interestingly, before there was any confirmation of these coordinates, the Israel Twitter account shared this image showing that the lander had been observed on the lunar surface using the orbital high-resolution camera from Chandrayaan-2. This is the highest quality camera in low lunar orbit. It's superior even on paper to the Lunar Reconnaissance Orbiter's camera. So of course we can take this image and we can compare it with the predictions, and yeah, they're overlapping. It was pretty impressive. The interesting thing about this tweet, though, was that it was deleted minutes after posting and people wondered why. And it appears that they didn't want to spoil this and find a present that was gifted to Mr. Modi, an image which just happens to include the coordinates of the landing site. So where is this? The Apollo 11 site, the site that Chandrayaan-3 landed at, was within about 20 degrees of the South Pole. They'll talk about it being a polar lander. But 20 degrees out is a fair distance from the pole. On the other hand, 20 to within 20 degrees of the pole is 3% of the lunar surface. So India is definitely the soft landers. So far there have been hard landers that got closer to the South Pole, including the impact probe on Chandrayaan-1. Speaking of impact probes, it's worth taking a look at where Luna 25 ended up on the same map. As of right now, we don't have a definitive impact site. It may have been an image, but we certainly haven't found it at this point. We do have coordinates from, derived from the final orbit that put on the edge of this crater as the terrain rises. If we do get anything out of the Luna 25 investigation, I won't be surprised if it's blamed on a software problem, because that seems to be the problem that everybody has in the barrel sheet. Chandrayaan-2, for example, it's very much the way that things go these days. Chandrayaan-3 succeeded partly because they corrected the problems, and partly because they tested all the potential things that could happen. In the end, the landing was actually flawless, and all that extra work wasn't necessary. But I think it was necessary so that they could actually exercise their entire base. Friends, what are your thoughts about this? Do let us know by commenting below. You can show your support by sharing this video with your friends and family. Make sure to subscribe to our channel and click the bell icon.